All right, and welcome back. So in this video, as I said at the end of the last, Nelson will be implementing our GetRecordDataToStore, WriteRecord, and OverwriteHeader. Get those implemented for us. All right.
Okay, OverwriteHeader is going to be very simple. It's going to say writer, base stream, seek, and then what am I doing? Header position, and then seek origin from the beginning. And then we're just going to say header write to writer. So that's OverwriteHeader. WriteRecord is also going to be fairly straightforward. The first thing we're going to do is we're going to base stream seek to the record position that we need to write this record to, with the seek origin at the beginning. Then we need to write the header. Then we need to write the body. And finally, I'm going to go ahead and just flush this stream. So we can have at least a, I mean, it's not the same thing as an atomic write that you would get from an RDBMS system, but more or less, if execution gets to here, then at that point, this record will be saved in its entirety to the database system. We're not going to have to worry about a crash destroying a bunch of pending writes.
Right.
Okay, so the GetRecordDataStore is actually going to be a little long because of stuff. We're going to have to instantiate a new record header that's going to represent the record that we're storing. We're going to have to create a memory writer so that we can satisfy the interface of our iRecord save method being passed in only a binary writer. And then we're going to have to copy that data into a byte array and return it. So the first step is the new header. And we're just using the default constructor here. The coordinates is going to be info.coordinates. The layer is going to be info.layer. The next record is going to be -1. The type is going to be record get type. The version is going to be record.version. So that's pretty straightforward. Then we're going to say var using memory writer equals new binary writer, and then new memory stream. And then I'm just going to go ahead and say allocate 256 bytes for this. I mean, whatever. Just a buffer of 256 because I like that number because it's power of 2. Then we're going to go ahead and save to the memory writer. So we're going to tell the record to save against this memory writer, which is just saving against this memory stream. Now we know how big the record is going to be, so we can just do new header data size equals uint memory writer dot base stream length. So that's how much data we're storing. Now this is fun. We're going to access the memory stream directly by doing casting memory writer base stream to memory stream, and then we're accessing his buffer with the getBuffer method. Now we're going to allocate a new buffer, which is going to be a new byte array of memory writer dot base stream length. Now we're going to use the buffer.blockCopy helper method, which is just going to copy one buffer into another. So old buffer, we're going to start at 0. Our destination is going to be the new buffer. Our destination offset is 0, and our count is going to be the new header dot data size. Now we can calculate the checksum. So we say new header dot checksum equals new buffer to MD5, which we'll implement in a second, and then we're going to return tuple.create new header new buffer.
Okay.
So yeah, these are our 3 methods, and like I said, I'll implement to MD5 in a second. But do you have any questions about these particular methods? All right, so to MD5 is going to be pretty easy, straightforward, blah blah blah. It's just a extension method. So I'm going to make a namespace called extensions, and I'm going to create a array extensions. And it's going to be an internal static class. And it's going to have a private static read-only MD5 crypto service provider. Maybe if any of you have seen the ASP.NET series, I mean, I hope you guys know what a hash is, but if any of you have seen the ASP.NET series, we used a SHA-1 hash instead of the MD5. The reason I'm using the MD5 here is because although MD5 isn't as good for storing things like passwords than SHA-1, because SHA-1 has fewer collisions, it's a lot faster than SHA-1.
Mm-hmm.
And at this point, that's what we care about the most, is how fast it is. Because we don't want our load record, which is going to check for corruptionness, we don't want that to take forever.
Right.
So I'll have a public static string to MD5, this byte, that. And we'll start out with a character array. And the MD5 is 32 bytes long. We'll get our bytes by doing MD5 compute hash that. And then finally, we're going to go ahead and convert this, because this is just going to return an MD5 not as a string. It's just going to be a bunch of data, raw data. And even if we were to encode it into UTF-8, all we're going to get out is gibberish. I kind of really do like the way you usually represent MD5 hashes and most hashes, which are in nibbles. A nibble being a hexadecimal digit.
Mm-hmm.
So that's what we're going to do here. We're just going to go ahead and convert this into the binary representation of this hash into a string representation of nibbles. And I'm using a for loop and a pre-computed character array and all that goodness, just so it's a little bit faster than if I were to do this manually or automatically with some other thing. So our nibble is going to be bytes I toString X, and then X is the format for turning a byte into represented with a hexadecimal character. Now the problem, though, is that the nibble actually lied about something. Nibbles are 2 bytes, or not 2 bytes. They're 2 hexadecimal characters, or are they? Wait a second, am I confusing myself? Oh no, I'm not confusing myself. They are one single hexadecimal character, but the issue is that they why am I drawing a blank right here? Basically, the point is we're trying to normalize the length of the string. Occasionally, that X, turning a single byte into 2 nibbles, will return a single digit. So this might return, like, for example, if it were 5, it's going to just return 5, right?
Mm-hmm.
If it were 16, it's going to return A1.
Okay.
So what we have to do is we have to add some padding to make sure that if it's under 16, we're going to add a little level of padding so that it looks a little bit better.
Gotcha.
I don't know why that took so long to get out of my mouth. So if it's under 16, we're going to set the character arrays, the current position in our character array to 0. So we have a little bit of padding so everything's consistent. Otherwise, we're going to say, and then we're going to say I times 2 plus 1 is going to be this nibble. Or nibble 0, sorry. Because this is a doohickey string. So then otherwise, if it's greater than 16, and base 16 are hexadecimal, if something's greater than 16, it's going to have 2 digits. I hope everyone knows what hexadecimal is because I don't want to explain it.
No, don't worry about explaining that. They should.
So basically at this point we're just going to, if the nibble is above 16 bytes, that means it has 2 characters, which means we can safely reference both a 0 and I times 2 plus 1 and 1.
Hang in there, Nelson.
So there's our painfully typed out method that turns a byte array into a nicely, neatly, uniformly lengthy MD5. And now we can use Alt-Enter, which is going to bring in the using World Data Storage Library Extensions namespace up here.
Mm-hmm.
So yeah, so that's getting set.
Okay.
Clocking in about 2:32, so that's not too bad for getting and setting data out of our system.
Right. Okay, so at this point, does this pretty much wrap up the actual database class?
More or less, with the exception of the advanced stuff.
The advanced stuff, right. Okay, fantastic. Well, ladies and gentlemen, that will conclude this video, and we'll catch you back in the next. We're not done yet.